Hello guys, let's start with our module 6, constraints and data integrity. So in this particular video or chapter or module, we are going to understand about the constraints, how constraints are applied in SQL and how a data integrity is preserved during the complete period of writing the queries and all that stuff. So let's start with the first video of the module name primary key and foreign key. So as you can see from the name, chapter name here, that we are going to study about the primary keys and foreign keys, what basically they do and how they perform in SQL. So let's begin with it. So first, let's try to understand why constraints and data integrity. Fine. Let's try to understand this scenario first. In short, okay, or you can say in depth also, same thing. So data integrity means what? It means to keep the integrity of the data, right? So basically means ensuring data is accurate, right? That is the main integrity of the data. What is data? If data is faulty, then what is the use of the data, right, in the further process? So keeping the data integrity is what means the ensuring the data is accurate, along with it consistent. Okay, data has to be consistent. Suppose if previously it was a plus b, then after that it should be b plus a plus b. Okay, it should be the same. So that what its consistency means. Along with that, it should be a reliable one. Okay, so this ensures a data integrity. Okay, what do you mean by reliable? Reliable means a reliable car, right? So if it gets and hit to a wall, it should protect the person within it, right? Basically, if the brake fails of a car, okay, so it should protect the data within it. Data is the person, the living being, right? Similarly, when while we are storing the data, while we're retrieving the data, while the data is getting processed, if something breaks, right, so data should be present after that or before that. That is called a data reliability. Okay, so this complete three things makes up to a data integrity. Okay, now constraints. Let me go to a new page to understand that. Constraints. Okay, so constraints means rules enforced by DB to protect data integrity. Correct? So if you can see, it's like suppose, let me draw with this. Suppose this is an infinite loop. Okay, this is data integrity and this is constraint. So they are hold to each other. Okay, so but we know that we need data integrity. To have data integrity, we need constraints. If we have constraints, we have the data integrity. Getting my point? So this goes this way only, correct? I hope you're getting this part. Okay. Now, what I will try to do here is that I drew this in middle, so no issues. I will just do this. Okay. So what happens if I say without constraints? Okay, what will happen? First thing, it will have duplicate datas, correct? No consistency, no reliability, right? Second, invalid uh, references. Fine. Third, data becomes meaningless. Okay. So these are the scenarios we will be facing if we don't have the constraints with us, right? So I hope you understood the relationship between both the data integrity and the constraints, how they work and how this particular loops defines the thing, right? So this is what is data integrity and data constraint in SQL. It's very easy, very straightforward, nothing to make it complex. Okay. So now let's move forward. So since you understood the concept of constraints and data integrity, so let's try to learn about primary key, the first constraint. Okay. So if I say definition of a primary key, okay. So what I will do, I will type it down. It basically means a primary key is uniquely, alright, uniquely identifies each row. Second, it cannot be null. Third, cannot have duplicates. Fine. Primary key. What is the primary key? Primary key is that suppose I'm a person, okay? So I have some principles in my life, and those are three core principles that I'm uniquely identified by everyone. I am not a null, okay, and cannot have duplicates. I know this analogy does not make any sense, but yeah, a primary key has a property that it has to be unique. Basically, if something is primary key, if uh, if something is primary key, suppose a pen is a primary key, then it has to be unique. Okay, it has to be unique. It cannot be null. Okay, it cannot be null, and it cannot be duplicate. It cannot have duplicate values, right? So if pen 1 is there, there cannot be another pen 1. It has to be pen 2. Okay, so this is what a primary key is. And you will be thinking, what kind of data can be a primary key? For example, if you are an Indian person, right? If you stay in India, if there is an uh, what we call it a government identity card, okay, then it will be a Aadhaar number, right, or a PAN number. So each individual will have these things, correct, and everyone will have it as unique, correct. It cannot be other. Suppose social security number or a government ID cannot have duplicate values. It has to be unique, uniquely identified in each in every manner. Secondly, it cannot be a null value. They cannot hand you an empty card with no ID in it. Third, the data cannot be duplicate. Fine. Or you could call, or if you take it as a roll number, okay, you can take a roll number also. This is an analogy. You can take a roll number also. Suppose roll number, social security number, right? So these are the things where which helps to identify a person uniquely. Okay. So this was all about the understanding of the primary key. So let's go to our MySQL workbench and try to understand the syntax for the primary key. Okay. So we'll write here primary key and then the syntax. Fine. Suppose I'm trying to create a table with a table name. Fine. Then what I'm going to do, I want to have a student ID and I want it to be a primary key. So I can just type it out as this way, primary key. Fine. And suppose should not write it this way, rather column 1, okay, or column name, and so on. But keep that in mind that uh, note always one table can have one primary key only. Fine, keep that in mind. I cannot create two primary keys altogether. Okay, so let's try to create a table. Create table students. Fine. There I want a student ID and I want it to be an integer type and it has to be a primary key because I want it to be unique, null, sorry, not null and no duplicates. Fine, because always ID should follow this criteria always. Then there should be a name of varchar, suppose 50. Okay, and make it comma. Come back here again. Let there be an age of int data type. Make sense now? Okay. Now what I could do, I'm going to control plus enter to create this particular table, and if I refresh this, you can see that student table has been created with this particular columns. Fine. So you understood the syntax here? This is a syntax basically. You just have to write the thing here. So if rather I could write it this type, yeah, that makes sense. And rather than writing here int, what I'm going to do, I'm going to write here data type. Fine. Now here if you can see, the student is unique for each student. Okay, the student ID. So DB automatically enforces no duplicate values and no null values. Make sense now? Now what I'm going to do, I pasted this insert query here, and this is a valid one. Okay. So what I'm going to do, I'm just going to select all of this and click on this button. So all of these two values have been inserted here. Okay. Now we'll click this button here, and I can see that this data has been inserted here. Fine. Now what if I try to put in an invalid value? So I just added this invalid value here, invalid query, I mean, and I'm going to select first. I will try to run the above one, 19th row number. It is throwing an error. If you can see here, it says that insert into students, duplicate entry one for key student primary. Okay. So if you look at the data, we already have the student ID with one. So that is why it is throwing the error. Now, if I try to insert into students values null with null, okay, it is throwing the error again. It is saying the column student cannot be a null value, right? It cannot be. So this becomes the. So I basically tried here entering a duplicate value first. Okay. So this is a duplicate scenario, and this is a null scenario. Fine. Okay. So here we try to understand the basic structure of the query primary key. So what I want you to understand more about is that actually more on primary key. Okay, just let me give the heading here. More on primary key. Fine. So there we understood the basic query, basic understanding of the primary key, the core part. Now I'm trying to give here something new or more, I would say. So let's start by understanding composite PK. When I say PK, it's with primary key. Okay. And what does composite means? Composite means when two or more columns are grouped together to uniquely identify a data. Okay. So when you want to uniquely identify a particular row, a particular scenario, what you do, you identify you group column A, B, C, and make them one primary key. Okay, that is called a composite. That is the meaning of composite. Fine. And when someone says composite key, similarly, when you merge through two, three columns all together, it becomes a composite key. Got it? So let's try to understand here. Suppose if I try to create a table, enrollments, fine, and then I type here student ID integer data type, and it has nothing. Okay, just comma, and then course ID, that to integer. Okay, then what I'm going to do, this is another format. Fine. First I will give you the way how it's written, then I will give you the syntax. So what I'm trying to do here, student ID and course ID. Okay, and then I will give the syntax here. I'm gonna copy this, paste it here, and remove this part. And suppose there are multiple columns here, and then what I'm going to do, I'm going to write primary key. Okay, column 1, column 2, and so on. Okay, so this makes sense now. And coming back to this particular thing now, and create table enrollments. Yeah, so you can see here I have taken student ID and course ID to identify something. So this means a student can take multiple courses, but same student cannot enroll in same course twice. Okay, so if I want to write the meaning of this particular thing, I will write it here. A student, okay, can take multiple courses. Of course, student ID 1 can take multiple courses of course ID 1, 2, 3, 4, 5, 6, 7, 8. Okay, but same student cannot enroll in same course twice. Got it? This is the meaning of this particular statement. Okay, so this was all about the understanding and more on primary key. Fine. So I hope you understood this particular scenario with this particular syntax. Now coming back. Now let's go ahead with understanding foreign key. Okay. Foreign key. So what is a foreign key? Let me give you the definition here. Okay. A foreign key is first links one table to another table. Okay, another table. Keep that in mind. Secondly, ensures referential integrity. Okay, if I take an analogy of a real life scenario, so I can say that orders, okay, must belong to a customer, correct? Then you cannot order without being a customer. Makes sense? So here, customer table and orders tables are referenced or linked using this foreign key concept. Okay, so let me show you the practical, then it will be much more clear, and then I will try to give you more easy explanation to it. Okay, so if I just write here foreign key, okay, and syntax, it's basically very easy. It says that create table, then the table name, of course, let's do it column one or this the column name with data type, then we can suppose mark it as primary key. Okay, and suppose we have multiple columns, column 2, column 3, etc. Fine. Now we have suppose table, another table. Okay, create table, table name. Fine. Then suppose there is a column name with a data type, and this is also a primary key. Make sense now? We have more column. Then again with that we have another column. Suppose let this be column name 1 and column name 1. Here column name 1 both are same. Okay, to make that differentiate, what I'm going to do is that column name 1 equals to column name 1 from the fk table and the pk table or the first table, whatever it is. Fine. So I created this column 1 here. Okay, again, and with the data type. Fine, data type. So syntax comes out to be like foreign key. I want the column name 1, okay, of this fk table where we are having this particular thing. Okay, references the let me do one thing. Okay, to make it much more clear, table 1, table 2. Okay, and this is done, this is done. Let me just copy this, copy. Makes sense now? Fine. So of the table 2 references, the table 1 column name 1. Got it? So basically the column name 1 of this becomes a, it is not necessary, before going ahead, it is not necessary that a foreign key has to be a primary key in the second table, which is a foreign table for the primary key table of the table 1. So here if you can see this column name, I have created this a foreign key because this column name 1 and this column name 1 is same. Basically, if this is a department ID, this is also department ID. These are the same, and this references this table 1 with this column name 1. Got it? To understand this more, what I will do, we'll take an example here. So I pasted these two queries here. This is becomes the parent table, okay, and this becomes the child table, okay. Now, please listen clearly. This child table can be a parent table to itself, okay, but for this parent table, this is a child table, okay, and this child table can be a parent table to any other third or fourth table. Make sense? And why I'm calling this as a child table? Because if you can see here, department ID and department name, okay, and department ID is the primary key here. And suppose here department ID is not a primary key, but in table one, this department ID is only one thing which identifies each row as not null, not duplicate, and unique properties of primary key. Fine. This helps in uniquely identifying a row and the data also along with it. Now, if we come back here, here employee ID does the same thing, but for the employees table. But if we want to join these two tables and want to understand that which employee is in which particular department, we need something to link them. Correct. So in this particular scenario, this department ID will help us a lot. Okay, because this will have the same data as this particular thing. So if you can see here the syntax, the foreign key, we're making this as a foreign key, which should reference a department's table with department ID. So whenever I try to join these two particular tables using the join query, which we will learn in further chapters or further videos, this will help us a lot to connect these two particular tables. Got it? We run this. Okay, both tables are created. I hope this is making sense to you how it's going, right? So department ID in employees must exist in department. Okay, so what's happening here is that department ID in employees must exist in departments. Correct? Then only they will be able to connect and figure out the data that for employee one having a department ID 2, does that employee exist in the employees table with department ID 2? Got it? So this helps in preventing invalid references. Okay. So I will try to enter this valid data first. Okay. I'm putting this in departments. I'm putting these two things. Department has what? Department ID and the department name, and then this below one, which has the employee ID, name, and department ID. Got it? Now, if I just see these tables, both of the tables, you can see here is that we have this department ID here, and we have this particular thing. Got it? Now, what if let's try to take an invalid scenario. Insert into employees table because this is a child table. Okay. Values 102. Suppose Mike and ID 3. Okay. Let's see what happens. It is throwing an error. It's saying that cannot add or update a child row. A foreign key constraint fails because we don't have any ID 3 department ID present in our department table. And as soon as if I just copy it and paste it here again, uh, suppose resolution. If I just give a resolution for it, if I just paste this here and if I just make it ID 3, suppose, and I will make it as a software department. Okay. Wait, something is wrong. You have a single syntax. Just a sec. Okay, because of this, we'll run this again. This ID has been added in our departments table. Okay, look, and now if I come back here and if I try to add this particular invalid case, it got added because look, see here, because we have this department ID present here, right? I hope this making sense to you now that how it is working, the relationship between both of them. Okay, so this was the syntax on how a foreign key and primary key works. Okay, now let's come back and try to understand something of referential integrity. What was the name of the chapter? It was saying constraints and data integrity, right? And now we're trying to understand referential integrity, which basically belongs to foreign key. It ensures child table values must exist in parent table and no orphan records are present. You know the meaning of orphan? Orphan means when a child does not have a parent, correct? So if child table values must exist in the parent table, then and only a referential integrity will have take place. Okay. So this was main concept on understanding foreign key and primary key. Okay. So since we have got the understanding of the referential integrity now, I want you to learn some more advanced concepts, or I would say a more advanced the things which are not usually taught when we are given the knowledge of primary and foreign key. Is let's go upon and try to understand few of the more things. So I will just give a rough heading here that let's try to understand the dependent constraint. Okay, let's try to understand this particular thing. Now these are dependent constraints on foreign key. Okay, so the constraints which are dependent here for the integrity purposes basically are on foreign key. So there are three dependent constraints. Okay, first one is on delete cascade. Second one is on delete set null. On delete restrict. Okay, and this is the default format. So here if you can see that this is the delete keyword here, right? Delete keyword, cascade keyword, delete, set null, delete, right? So we till now we have not studied about delete command in SQL. Okay, so you don't worry about how a delete command works, but delete is a delete, right? So when I delete something, it will delete a particular row, particular column or something like that. So that is how a delete keyword works in SQL. Okay, so let's move ahead and try to understand this in more depth. So what I'm going to do that in the practical, I'm going to create tables, okay, and insert some common data in it, and then we're gonna perform all of these three dependent constraints. Fine. So I pasted these two commands here, and as you can see that there is already departments and employees tables is present. So what I'm going to do is that I'm going to drop both of them. Okay. So drop table departments, comma employees. Fine. So um, wait, just me check. Yeah, both the tables got deleted. Let me clear this. Now we'll create them again. Okay, both of them got created. Okay, so there is nothing to learn here. It's just a simple creation of tables. Okay, and now I'm going to add the data. So I brought down this query for department and employee. So I'm going to insert this data here. So I guess that is also done. Let me open this employees table and let me check. Okay, it did not got inserted. Okay, I should have clicked here. Okay. Now if I run this query, I can see the data. If I come to departments table, I can see the data here. Fine. So everything is great. Okay, let me run this also. Now if I go and click this, I can see the data present here. Fine, this is clear, straightforward, nothing else. Now we are going to apply the rules line by line. So let's start. First one is case one, on delete restrict. Okay, default. This is default behavior. Okay, what I'm going to do, I'm going to alter the table employees and add constraints. So look, we have already studied the syntax of how this alter works, right? And this constraint, when I write here constraint name, this is the name of the constraint. Okay, fk department foreign key. What is our foreign key going to be? Department id, and it references departments table department id. Makes sense now, as we have already studied how it works. Then I'm going to add a new thing here. Usually it ends here, right? But no, this time I'm going to add here on delete cascade. Okay, sorry, restrict. If you remember from the previous part that I was trying to delete and it was not allowing me to delete or insert data because foreign key and primary key had some relationship, right? Now look, this has been created. Okay, so this is our syntax. This is the new line to be added. Okay, now if I try to delete, now before going, look, when there is a primary key and foreign key relationship is created, so we don't want that our data gets deleted uh, inconsistently. That means if I delete something in the foreign table, it should not be present in the parent table. Okay, or it should be present in the parent table. Suppose if the parent itself is not present, then what is the use of child? How child got created? Getting my point? So that is why we have to keep that in mind, that the relation is consistent. So suppose if I try to delete from the departments table, and here the departments table is a parent table. Okay, where department id is 1. Okay, look, it is saying that cannot delete or update a parent row. Foreign key constraints fail. Okay, because, okay, let me write here, it fails because database is protecting the data employees. Because if I delete the department, right, look here, here sorry, here department is the parent, right, and employees becomes the child, correct? So if I delete the department, so employees are dependent on department here currently, right? So if I delete the parent itself, then how a child going to relate itself to a parent? Make sense? So that is why employees still belong to this department. So I cannot just go and delete the department. Okay, so this basically makes a restriction, and this is a default restriction. Even if I don't write on delete restrict, it is going to work. Make sense? Now coming to our case 2, on delete cascade. Okay, so this is an important one. So let me first drop the foreign the constraint which I created. Okay, alter table employees drop constraint fk department. Okay, so this has been deleted. Now again, what I'm going to do, let me just copy this. Okay, and I will paste it here. Syntax, I will add something like this. Syntax, paste it here. Now, now look, again I am going to do the same thing, and instead of restrict, I am going to do cascade. Okay, Make sense? Now, if I suppose what I was trying to do here in the above, what I was trying to do, I was trying to delete the parent. So it was throwing the error that the child is dependent on the parent. So please don't delete the parent instantly. It is not allowed. Correct? Now I want that if I delete the parent, I want the child also to be gone. Right? So what I'm going to do here. So this is what a cascade does. Okay. Delete from departments where department ID equals to 1. Okay. Now please keep that in mind. In employees, we have two rows here and we have one row here with one department ID 1. Okay. Let's see how it works. It got affected correctly. Now what should happen? It should get removed from the department, which it did. Also, it should get removed these two rows from the employees table, which currently got removed. Right. So you can see that it worked correctly. So this is what means that department department got deleted and employees Rohit, sorry, Rahul and Amit also deleted. Meaning, if parent deleted, child also gets deleted. Row only. Okay. Now let's move to the case 3. Now since I have deleted that particular row here, so what I'm going to do is that I'm going to insert, it was row 1, right? I'm going to insert this row and I'm going to insert these two values also along with it. Let's come back here and let's check, do we have those values now? We have here Rahul. Okay, since we have here Rahul, means it got, this one did not got inserted. Okay, now we have Amit also. Okay, we're back to our data and here also we are back with our data. Fine. So what I'm going to do now here is that it is the case 3. Case 3 means on delete set null. Okay. So for that, since I already reset the data, so I'm going to drop that primary key which we created, table, and before that, uh, show create table employees. Okay. So here I can see that the key is fk department, which is department ID, and fk department, the last line, if you can see, references the department. Okay, so I'm going to delete that thing. So alter, not this query. Where is that query? Just a sec. So it will be table employees. Okay, drop constraint. Please remember these queries. These are very important and very straightforward. Okay, fk underscore department. So this will delete the drop the the particular key. And if you can see here from the show table, fk department is a foreign key name. Okay, and why it is showing this thing? Okay, I will run this now. You have an error. Check the manual correspondence to it. Okay, I think some. Okay, so let me run this one. Okay, and if I run this particular query again, do we have that? Check the last line. We don't have it, right? The constraint got removed successfully. So that's correct. And let me just delete this and I will clear this out. And again, I will copy this. And instead of cascade, at the end, it will be on delete set to null. So what it is going to do is that it will delete the parent table and the dependent table and row will become null. By means that last time Rahul and Amit got deleted, right? So rather being getting deleted, this will become null. Okay. So let's try doing that. Let me run this command. Okay, so this is created. Again, I will run the create show table and let's check. Okay, the last row it's present there. Fine. Okay, let's try to delete the data now. Delete. from departments. And please don't worry about this delete command. We will learn about this in DML topic. But this is how a syntax work, right? Where department ID equals to 1. So it got deleted successfully. Let's check here. It is removed. Coming to employees. Look, the department ID got become null here, right? So this is how, when we don't want our child to be get deleted, we use this particular set null function. Okay, so it basically does what? Removes the parent data but keeps the child data and replaces the column value with null. Okay, so guys, this was very important and crucial topic. You should be knowing these three things. This are very important, and this puts you up into an edge that you know better. You know, you have much more knowledge on foreign key rather than just creating the foreign keys and primary keys. Okay, so what I'm going to do is that just make a note here. So if it is on delete, okay, if it is on delete cascade, that means that if parent deleted, child auto deleted, fine. On delete set null if parent deleted, child becomes null. 1, 2. Then comes third, on delete restrict, which is a default behavior. Okay, default behavior. It basically it prevents deletion if child exists. It prevents deletion of parent. I will write it as this: parent data if child exists. Okay, so this is a summary of what it is. Now I hope these three things are understandable to you, and this is something unique thing you should be knowing. Again, I'm going to say that. So let's try to wrap up this thing by understanding the last thing, which is common mistakes. Okay, so what are the common mistakes people usually do? First thing, using duplicate duplicate primary key, which is not allowed. Forgetting foreign key relationships, fine. Third, deleting parent without understanding cascade. Fourth, not handling the null cases, fine. So these are the common mistakes which people usually forget and do it. So this, now you should have the knowledge of this very clearly now. So this is all about the primary key and foreign key, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is unique and not null. So these are the two other constraints which are mostly used in SQL. Unique, from the word you can figure that out, and the not null, something which is not null. Fine. So let's move ahead and let's try to understand how these things works. Okay. Let's write why do we need these constraints, right? Why these constraints? Because there has to be some meaning, right? When we are using something, there has to be some logic and meaning behind that. Because not every column is a primary, I would say, key. Okay, not every column is a primary key, right? But still need rules, right? You cannot go and put every column as the primary column, right? That does not make sense, right? So we have to divide the rules. We have to create new rules so that we can have a walk around of it. Okay, still need roles. Fine. Okay. And let's try to understand why we need this. I will type it out. Okay. First reason comes out to be some fields must always have a value, right? Basically meaning not null. Second point, some fields must be always unique, but not a primary. Okay, so it comes out to be the unique. Fine. Now, name of a person cannot be a null when we try to fill up a form, right? It is a required one. Second most, uh, the driving license numbers, or in a company if there are a number of employee IDs, those all has to be unique. They cannot be a repetitive, or you cannot make it a same one. Fine. So that are the two differences to understand in a shorter form. Okay, so make it like this. Great. So let us now start with null. Okay, not null. Okay, let's start with this now. Constraint meaning, now we already know, but I will write it again. Column cannot have missing values or missing value, meaning null. Okay, so it cannot have any null values. So let's get back to our MySQL workbench to understand how the syntax work. Fine. From our previous chapters, we already know that we are following a particular DB, right? So I will try to continue to use that particular DB. Okay. So let me write here not null and syntax. Now since it is a constraint, right? Constraint. A syntax will look like something like this: create table. Basically, this is a syntax for the table creation, right? So let it be table name. Then suppose column name. Okay. Then suppose data type. Then comes the constraint. Okay, and that constraint will be not null in this particular case. So this is the syntax. Okay, and it will keep on going, right? So it will be looking like this. So let's start. Use company DB. Okay, company DB. Okay, so we are inside the company DB database. Now what I will do, I will create a user table. Okay, so this is a script. Okay, so what I'm doing here, create table user ID, data type, primary key as we know already, name varchar, and it has to be not null. Look, we have followed the constraint rule here, or syntax, and there is email again. Fine. So now I'll run this. Let's see what happens. Okay, the table has been created. Let me check. Let me refresh. Okay, the user table is present here with the columns inside it. Now we'll try to insert some data. Insert into user, sorry, users value, user ID, then let the name be hers, and let the email be hers@gmail.com. Make sense? Okay, syntax is correct. Now we'll run this. The data has been inserted. Okay, now what I will do, let's check the data. Okay, look, we have the data present here. Okay, now what I want to do, I want to add null values to it. Okay, now let's see what happens. It is throwing an error. If you can see here, it's throwing an error that column name cannot be null. Fine. What if I run this again? Data has not been inserted, right? Because it is throwing a warning here. So what you will do? You have to insert something there, right? So insert into users values. Suppose 3 comma. Even if you try to put this two things here and just go like bansal@gmail.com, what do you think? What will happen? Let's see. It got passed successfully, right? But you might be thinking that, man, but the name is indirectly empty, right? Look, but it is empty. What to do? To understand that particular thing, we will learn that in our next chapters. Okay, there we will learn about a new one more concept of constraint. So there, from there, we can avoid this particular sin. Okay. So I hope you got this idea. Okay. Coming back to the slides, something you should be knowing that some fields are mandatory. Like some fields are mandatory, right? Like let me write it again. Like name. Okay. So so that is why we need the not null constraint, so that you don't keep everything empty. Okay. So this was all about not null. There is nothing much to explain because it's just a constraint which you have to apply, and I hope you got the reason behind it, that why we are using not null. Okay. So now let's move ahead and try to understand about the unique constraint here. Okay. Unique constraint. Now what is unique constraint? Okay. So the concept behind that is that uh, ensures no duplicate values. First thing. Second thing, but null is allowed, right? Please keep this in mind. This is very important point. Otherwise, you might get confused in interviews or when you are creating a table or something like that. Important. This is very important. But null is allowed because null is also kind of a unique thing. This is this is system which is built upon, right? The SQL thinks, okay, the null is there, right? Null means nothing, so it cannot be a duplicate. Correct. So that's why it ignores when we have this particular thing here. Okay, when you're using unique constraint. Now let's try to learn about unique. Okay, let me close this. We'll copy this here. Zoom. Create table constraint and just it's same syntax. Unique. Okay. And what I can do now is that let me copy this. One way to do. Okay. Like the email, you can put it as unique. Okay. I hope you're getting the syntax how it works. But what I'm thinking of that since we already have the users table, right, and we have the email present within it, correct? So what I'm thinking of to do is that use the alter command to update the particular column. If you remember what it used to be, using alter command to update the column. Okay, email. It was like alter table. If you remember, table name which is users. Add. Okay, add what constraints? Constraints. Oh, sorry, constraint. Unique email. Okay, unique email. So we are applying the constraint in this particular column. Okay, and basically renaming it also along with it. Unique email. Okay, the original name of the column. Okay, let's try running this. It got successfully updated. So when I click here on refresh and go back here, columns, and I click on email, wait, it didn't got updated. Just a sec. So you can see that column in email definition is varchar. Okay, so what we have to do to understand whether this got updated or not? Yeah, describe table, which is users. So now you can see that email becomes our unique. Okay, so this helps you to also revise the concept of altering table. Okay, great. Now what we can do, I will try to insert some values within it. Okay, so first I will insert some valid. Okay, valid insert. So valid inserts. So these are some valid inserts which I'm going to do. We'll run it all together. Wait a second, it threw the error. Okay, let me. Okay, the issue might be because of this null, right? Wait, let me check once. I can see here that 123 is already present, and I can see Amit came here. Third is bansal at the gmail.com, which was from previously. Okay, so I have to just update this to 4 and 5. And you might be thinking why I'm doing this, because if you see here, it says that this 3 is a duplicate entry because of the primary key, right? Because if you can see here, I already had 3 present from the not null lecture, not null section, correct? So that is why what I have done now, I have started it, the Neha and the Sara, I have started it from 4 and 5. Now let's try inserting it. So it got inserted correctly now. Now if I go to users and run this query again, okay, I can see that Neha and Sara has been inserted. And if you can observe here, since our email was the unique one, right? So Amit got inserted successfully. Null and none also got inserted successfully. Look, right? It didn't throw any error, correct? Now let's try to figure out the invalid ones. Invalid inserts. Okay. So this is the invalid insert, and what is the invalidation here? Basically, it is the email. Okay, so we are putting the same email again, and we know that email cannot be same. It has to be unique all over everywhere. Correct. So let's try running this. It is throwing an error here that okay, this is a wrong error. Let me try again. Forgot to update the primary key. Okay, now it's giving the correct error. It is saying that duplicate entry amit at gmail.com for key users or unique throws an error. Okay, this means that it is already present there. If I try to run this query, look, it did not got inserted. And what if I do just amit 2, and if I run that, then it will of course automatically get inserted into the table. Okay, so coming back from there, from the whatever we saw here, the syntax and everything, email should be unique, correct? But not everyone may have one, correct? This is very important to understand. Look, email should be unique. And even if you go and create an email in Gmail or Outlook or Yahoo, Hotmail, anywhere, for that particular domain, all the emails will be unique, correct? And suppose if there is 123 at gmail.com and 123 at the rate yahoo.com, of course, both of them are unique because of the uh, domain at the end is different. But if someone does not have the email with it, suppose I don't have the email, right, but I have to create the account, what I can do? So in that particular scenario, when the unique is used in this particular concept, you can now clearly differentiate it that okay, I have put the thing unique because I want the emails to be unique. But if someone does not have, that also should get accepted when the value is null or when the email has not been entered there. Okay, so I hope this is making sense to you now. Why we should be using unique constraint in some scenarios. So that is why. So null is allowed, but duplicates are not. Okay, well, and let me just draw this line here to just differentiate the thing. Okay, so I hope these things are making sense to you now. Okay, now let's try to understand the difference between, I would say, unique unique versus primary key. Okay, let's look at the difference. I know you people, if you know the knowledge of primary key, you might easily break down what is the difference between both of them. Okay, but then also let's try to understand. Suppose I will represent primary key as pk here. Okay, and unique as of course unique only. And let me write down the features also here. Suppose null, allowed or not, then comes the duplicate, allowed, then comes the count, per table. Okay, count per table means how many primary key we can have in one particular table and how many unique we can have in a particular table. Okay, so primary key, can it be null? Is it null allowed? No. Is null allowed? Yes. Is duplicate allowed? No. Is duplicate allowed in unique? No, of course. Count per table has to be one. It cannot be two primary keys. Okay, one only. And unique can be multiple. Multiple allowed. Okay. I hope this is making sense to you now. The difference also. It's just pretty clear. Okay. Now I have a bit curiosity to make you give you some examples on using two constraints all together. Suppose if I'm creating a table as, we zoom it, create a table, suppose employees. Look, I already have employees, right? Staff. Okay, let's create a table staff, and suppose staff ID. Okay, staff ID. Suppose there is a staff ID, integer and primary key. Simple. But now I want to create another column email having varchar as suppose 100. Okay, it has to be unique. Now, along with that, I'm saying that it has to be not null. Now, you will be saying that unique plus not null boils down to a primary key features, correct? But please keep that in mind, as we just studied in our differences, that there could be only one primary key in a complete table creation. There cannot be two primary keys, correct? So that is why to have that particular feature of primary key, that it has to be unique also and not null also, we are using both of them together. Okay. Now I will just run it. Table has been created, I guess. Let's see. Staffs has been created. Oh, sorry. Staff has been created. Staff ID and email. Okay. So this is one of the examples of how to use multiple constraints together. So we'll write it down. Multiple constraint together. Unique plus not null equals to primary key. I might write it this way also, I guess. If an interview or someone asks you that I want you to make a column as a primary key, but since already there is a column present there having the name as having the constraint as primary key, how you can do it using other constraints? This is a very simple question, right? If you don't know the logic, you might get a bit confused there, or you might have to take some time to understand. But this is what it is. Also, I just want to give you more examples on using multiple, or I will write it as multiple unique constraints. So these things you should know, right? So what I will do. So I pasted this here. Okay, let me just end this statement. So create table students which are having the multiple unique constraints. So this is the way you can use multiple unique constraints in a table creation. We'll run this and describe table name students. Fine. Look, both of them are unique. Now we'll just give you another example of composite unique. Okay, composite unique constraint, I would say. This is a bit of a advanced or a bit of a new thing you might be learning here. Look, I have pasted something here. It's a table creation script saying that there is a student ID, there is a course ID, no primary key, nothing. Keeping it as simple. Now what I'm saying that student ID and course ID both has to be unique altogether. Now this is a bit of an advanced concept here. Okay, which is not used so much, but you should be knowing the thing. Okay, first let me run this, then I will tell you what is the meaning of this particular thing. Describe enrollments. Okay, look, it is saying mul, mul. That means that multiple unique keys or something like that. Okay, so this basically gets full form to this particular thing. Okay, now the meaning for this is that, let me write it here, same student, same student cannot enroll in same course twice. Okay, but same student can have multiple course, of course. Okay, second, same course can have multiple students. Meaning, social science is a course which might have ID1, ID2, ID3, ID4, ID5, ID6 student ID. Okay, basically students. And whereas a student ID1 can have social science, science, history, geography as his subjects. But student 1 cannot have social science two times within its timetable, right? He cannot enroll in two courses altogether because you're getting the point, right? So in that particular scenario, I'm putting it this way that student ID and course ID has to be unique. Okay. So I hope you're getting this point. This is very important one. Okay. Now coming back to the PPT, and I hope you got this. Let me just close this down. And yeah, this is the thing. Okay. Coming back to the PPT, I want to give you some notes on common mistakes, I would say. First one comes out to be thinking unique is a primary key, which is not. Second, forgetting null is allowed. Forgetting null is allowed in unique, right? You might forget that if there is a unique, then there is no null allowed, but null is allowed. Okay. Third, not using not null where required. Okay. Fourth, adding too many unnecessary unique constraints. Okay. Okay. So these are the common mistakes which you will not be doing now because you have the understanding of things now better. So this is all about unique and not null, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is check constraint. So in this particular chapter, we are going to understand how a check constraint keyword works during table creation or in a SQL environment. Okay. So let's start by understanding why check constraint. Okay. Right. Till now, what we understood that first we learned about primary key. Second, we learned about foreign key. Okay. Third, we learned about unique key. Fourth, we learned about not null. Okay, till now. And primary key means identity. Foreign key, in short, we can call it in a relationship. Helps in relationship creation, correct? Between tables. Unique, no duplicates. And not null, basically must exist. Values must exist. Okay. Now, but what about valid values? So if we continue the point, what about valid values? Right? What about them? Example. Example. Suppose there is an age as -5. Then there is a salary as 0. Then gender as XYZ, random, right? Now, age cannot be negative. Salary cannot be 0 if you're getting the salary, of course. And gender is male, female, trans, or whatever you're putting there, right? So, but it cannot be XYZ, right? So, so there comes the check. There is where check comes in. All right. I hope you're getting this point. We understood that we need primary key, we need foreign key, we need unique, we need not null. We understood the use cases and how it works. But what is the use case of check? So this is the main case of check. If you remember in the previous chapter when I was trying to let you understand about the not null one, if the column is not null and we are inserting an empty string there, it is still getting accepted, right? So we will try to resolve that particular scenario also here using the check. Okay, so here where the check comes in, right? The thing on. Okay, so let's move ahead. Let me write it here as let it be like this: check constraint. Okay, it ensures value must satisfy a condition. Okay, it ensures that value must satisfy a condition that a should be great, should not be negative. A salary cannot be 0 and gender cannot be xyz. Okay, so if I try to make it much more clear, it's like not null checks if value exists, right? And a check check checks, this is a keyword. Okay, if value is correct. Makes sense now? Not null, which is a keyword, checks if value exists, and check keyword checks if value is correct. Got it? Now let's get back to our MySQL workbench and try to understand the syntax and the few examples with it. Okay, I'm going to write the syntax something like this here, that we're learning for check, right? Check syntax. It's gonna be very simple. It's gonna be like create table name. Okay, I'm using the create table reference here, right? But you can also use alter table by putting when you are using the constraint or adding the constraint there, right? The thing is same. The thing is same here. It will be like column name, data type, then constraints, right? Okay. Similarly, when you use the alter command, then also it goes the same way: column name, then the data type if required, new data type, and then the constraint. Okay. We'll paste one query here for create table employees. Okay, and I will run it. Okay, it has been created. I will refresh this table and I will see that employees has been created. Great. Now here you can see that age int check. This is the correct syntax, correct? And here what I have done is that the age, the column name age should be greater than 18 always. Okay. This is a check which I am giving. Insert into employees. Okay, and let the values be values. One, let it be the primary key. Let the name be hers. Okay, then age, let it be 19, and I will close this. Success, right? Now what I will do? You go and check for this value. Look, it's present here. Now I'm giving the age as 17 and key as 2. It is throwing an error here that check constraint employee check 1 is violated. Okay, so it is saying that in employees table the check 1 is violated. So check 1 is what? Basically the age, correct? So if we see here, if we run it again, it has not been inserted. Fine. So database is enforcing business rules that employees must be adult. Okay, I will write it down here that DB is making sure uh, that person is an adult. Fine. Yeah, let's move ahead. Now this was the core syntax and the core example. Now what I will do, I will create one more SQL query statement here, and it will be basically named as more on check. Okay, we'll paste this query here, the create table. In this particular create table query, what I'm trying to do here is that multiple conditions in check. What if there is a multiple conditions in check? Okay, so if I can say product ID is primary key, great, but the price data type is decimal, and we have to check that whether the price has to be greater than 0. And coming back here in the constraint part, I should just give an example that constraint name condition, right? This makes much more sense now. Okay, the price has to be less than 1 lakh, okay, or 100k. Now let me run this. This table has been created. I will refresh the column here, and look, here is the product. Fine. Now definitely what I'm going to do here, insert into products values primary key 1 and price. I'm putting it as -1 here. Let's try everything. Let it be 1 first, 100. Okay, then let it be negative and let it be 2. Let it be 1000, 10,000, 100k, 1 million. Okay, and let it be 3. Now we'll run this 3 all together. Let's see. Look, one row only got affected and it got shut down on the value 2 minus 100. And if I try to run this also, it will throw the error saying that check constraints product check 1 is violated, and it is also violated. So what we will do? Invalid, valid. Okay, and this is also invalid. And so if you want to see that what constraints are being applied there, so what you're going to do is that show create table name is products, right? Look, when you hover on over this, okay, you can see that constraint in product check 1, check price has to be greater than 0 and price has to be less than 100k. It is written here, correct? So following that, you can just figure out what's the wrong thing you were doing, and you can continue ahead. Now let's try to understand, or not try to understand, let's try to check about another one. Combine check plus not null. Let's try this. Okay, for this what you can do is that I will just create a table, create table names. Okay, and what I'm going to do, okay, nothing, just name. Let the data type be varchar with 50. Then it cannot be not null, and check will be name cannot be an empty string. Okay, let's try running this. Look, it got created, means there is no error. Names. Now insert, we'll try to resolve the previous chapter not null example here. Insert into names, and what if I do null first thing? Then let me close this. Then I will go for insert into names with some name. Then I will go with insert into name. Okay, okay, sorry, forgot to write here values, values, and I will keep it as empty string, right? So this was the one loophole which we figured out earlier, right? Null cannot be null because this comes from this particular constraint. Let's go with this. It got inserted, very good. Let's go with the last one. Look, names check 1 is violated. Now suppose again, if you don't know what was that, show create table. This is the query. Please learn this query and remember this query, or you can just Google it also. Names. When I hover over this, I can see that name is a varchar not null with a constraint names check one. Names cannot be an empty string. Okay. And if I just in this table and look, we only have hers present here. So I hope this is one of the doubt which was there previously is clear now that it cannot be null. Okay. So let's go with looking here, apply uh, a few examples like apply check using alter command. Like I previously said you, like we can use this also. So it's gonna be alter table, then table name. Let's suppose let us take products. Then we're gonna add the constraint here. Let be the name with check price. Okay, and check was like price was greater than 0, right? I will copy this, paste it here. Let it be 1 now. Okay, and everything seems to be same. And I will run this, and it got updated successfully. Now again, when I run this particular query, create table uh, to check what was the constraint about, it says that price has to be greater than 1. Okay, now, so what if I tried, we'll copy this, make it 0 and 4. Okay, it'll throw error that check price is violated because it has to be at least 1. Got it? Great. uh, let's also go with a drop constraint. Dropping constraint basically. Suppose if I want to drop something, right? Drop table products. Suppose from names I will drop the constraint. I want to drop the constraint check price. Now before running this, let me just run this query. So create table names, and here you can see that constraint is names underscore check underscore 1. Okay, keep that in mind. And when I run for the, suppose here the check price is violated, right? And suppose before doing anything, let me run this query again. Let me first close this. Where is the name one? Insert products, not products, names. Okay, so this should violate, right? For the names, I want to check one thing. Look, it is saying that names underscore check underscore 1 is violated. Now your question might be that how you gonna, that you might be having that question that add constraint, you're writing something here, right? So when you're trying to modify a constraint in the using alter command, you must be knowing this. Like from where I'm writing this particular thing. In previous chapter also you might have seen, right? The following thing. So it comes from here. I thought of putting this in notice to you that this check price is coming from here. So when I'm trying to update the dropping a constraint from suppose this names table, I want a constraint not because price is the column name, right? Not the constraint name. And this constraint name is given by the SQL by itself, right? So what I'm going to do, I'm going to write here names underscore check, okay, underscore 1. Then I am going to write nothing. That's it. I'm dropping this from the table names. I'm dropping the names check 1. Look, it worked, right? Now if I go into the so create table names and I run this, I can see that there is no constraint present as check. Got it? So I thought that I should be knowing this, and also with the other constraints it goes the same way. Okay, now I hope you understood all the syntaxes and everything here and all the examples I get. So now coming back to the slide, let's try to understand some important limitations. Okay, very important is that check works row label only, not column label. Okay, meaning cannot compare one row with another. Fine. Second, one table with another. Now, these are the small details and extra knowledge which you should be knowing to have an edge in your interview in the company you're writing something, right? Or if you're building a project, you should be knowing these checks, like these limitations of check or anything. But I'm trying to give you extra works here, right? So you cannot, like many people might not be knowing that what are the limitations. Like we cannot compare one row with another in using check, right? That's the biggest one. So, for example, what I'm trying to do say here is that if I try to do, let me just add here the section one. Suppose if I try to do check, okay. Suppose salary is a column present in an employees table, and if I'm trying to do if salary is greater than the department average salary, suppose this is another column present there. So this will not work, okay, because it works only row wise. So if you have observed here, price would be greater than price only. If I write here something else, it will throw the error, right? This is a very important thing you should be knowing, okay, very important. Okay, we'll just bring it here and mark it as read. Okay, uh, won't work. Got it. Now coming back to understanding common mistakes using check. First, thinking check validates across table, which we know it does not. Forgetting edge cases like 0. Third, writing too complex conditions. Fourth, not naming constraint. Okay. So these are the common mistakes which people do, that they don't name the constraints, right? So it becomes an issue for them to find which constraint was what, right? So this was like, so I tried giving you the important limitations of check. This was a very key point to this particular chapter, and also the common mistakes. So this is all about check constraint, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is default constraint. So in this particular topic, we are going to understand how a default constraint plays a significant role while creating a table or altering a table or basically a SQL environment. Okay, so let's begin with that. And before that, let's try to understand why default. Okay, so the problem is, the problem statement is like, sometimes user does not provide a value. Second, but we still want something meaningful stored. Correct? Basically, sometimes user does not provide a value. Like there could be scenarios that user does not provide a value for a particular column while inserting the data. Fine. So in that particular scenario, if a DB admin or architecture or the user does not want that column to be emptied, so a particular value is stored there, meaningful value is being stored there by default. Okay, So we want that a particular default value should be stored there. For example, uh, order status, right? So I cannot change the order statuses, right, as a user. Okay, but as a client or the or the owner of the particular DB can do something like set the status as in default scenario like pending. Okay, or an account balance should start at 0. So when you open an account, does not it has the automatically all the rupees or amount or dollars in it, right? It starts with a 0, which is the default value. Order status always starts with a pending status, right? Until and unless it moves forward with other, some kind of other statuses. So we want these things to be filled there if the user or the owner does not do it in the database. Okay, like instead of forcing the user, database fills it automatically. You can take it in that manner. Okay, so if user doesn't give a value, database gives a default value. So if a user does not give value, database gives a default value. Okay, this is what a default constraint is. Fine. So if I put a definition on it, a proper definition like default constraint. All right. So in that particular scenario, the definition could be like default assign a value automatically when no value is provided. Okay. So this is what a default constraint does. So this was all theory. I hope you understood why default came into the picture and why we need default. So let's now go back to our MySQL workbench and look at the syntaxes and how the scenarios, different scenarios are there to use the default constraint. Okay. So let's begin with the syntax. Default syntax. Fine. It goes like create table if you are while creating the table, not while altering the table. Create table name suppose, and then you go like this. Column name data type. Okay, and then the constraint, or I would like to say default. Okay, and the value. Fine. Let's suppose create table. Do we have orders table present there? No, right? Create orders table. And if I put an order ID here, an integer primary key, then order date data type, and it will be default. By default, it will be the current date. Fine. So I could just write here default or functions etc. Not etc. Functions integer. Suppose like this, right? The things could go like that. Current date, then status could be varchar 20, and for the default it should be pending. Fine, makes sense. I don't know why current date is throwing the error. Let me check. Let's see what happens. Let's try running this. I think this might throw an error because of this current date, but let's try. Yeah, so it's an error. Okay, so the resolution for this in MySQL is actually putting the current date within the brackets. Fine. Great. Now let's run it. Again, it's throwing an error. What it's saying? Okay, no database has been selected. Okay, so what I will do? Use um, company DB, uh, company DB, and then I'm going to run this command, and it's created. Fine. Now let's try to insert something. Okay, insert into orders, and I will mention the column name here. Okay, because if I don't, then it will throw an error. Okay, order ID, then values one. Okay, okay, I forgot to. So you have to keep this in mind. Okay, like that was not ended, so it's done. Now what I will do, I will just refresh this. I can see there is an orders column table here. Click on it, and I can see that order pending status for by default has been set here, and the order date is today's date, set by default. Right now, what? Now let's see. Describe, not describe. Show, create table orders. Right. This query gives me everything. You can see that order ID is not null. Order date is default with the current date, and status is varchar default with the pending, and order ID is also a primary key. Got it? Now what I will do, I will just copy this and I will just paste it. And what if I does not give this? If I do not give this, right? And will it run or will it throw an error? Let's see. It will throw an error because when you are not mentioning the odd column names, then you have to give everything here. Fine. Otherwise, if you are mentioning the column names, then it won't be throwing any error. Invalid syntax, I would say. Paste it here again, and now if I don't give and I go like 2, then date, right? Let's take the date from here itself. We'll just copy this and we'll paste it and we'll make it 24, and status would be completed. Fine. Let's see. Is it showing any errors now? No. Incorrect value. Okay, there has been something wrong here, I guess. Okay, it's done, right? I forgot to give the inverted commas here. Now we'll run this command again and look, we have tomorrow's date basically, and the status is completed here. So this is the core understanding of the constraint default. Okay. So from here we can also understand that default only works when we don't give any value from top. Like since here we gave the value from top, right? So it got overwritten. So this was a core understanding. Now let's go with by understanding more about default. Okay. It will be like this, that more on default. Okay. Let's zoom it. Suppose I create, now let's start by understanding with default plus not null constraints. Okay. It's a very what could I say, what I could say, very common combination. Fine. So it goes like create table accounts account, suppose ACC, and I'm going to create account ID, which is going to be integer and primary key, of course. Then a balance column name having decimal as 10 comma 2, which is, it cannot be a null value, and default will always be a 0. Fine. And I will run this. Successfully created. Describe table account. So it's present here. Correct. Now what I will do, insert into account values 1 comma. Suppose since I'm using this way, right? So I have to write here account ID, and it's 1. And when if I just refresh this here, where is it? Account is here, right? So I clicked on the wrong button. Just let this. Okay. If I click here, I can see that the account balance is 0.00 because we have done it in that way, like default value, right? But if I just do it another way, and we'll just give 10 rupee here, 19 rupee, suppose, or 19. Okay, it should be 2. Now it's correct. Let me run this. Look, it got overwritten. Okay. So these are some of the things like you should be knowing, and this query also says that like you might be thinking that what this particular thing do, right? Like condition. So it's basically saying that value must exist. Okay, and if not provided, 0 automatically. Got it? This is the meaning of that particular constraint and the not null default. Now let's try to understand default plus check. Let's try to get into this. Okay. So I pasted this query here. Here you can see that I have created a payments table with payment ID, amount where decimal is there, and check whether amount is greater than 0. And if you can see in status column, this default as pending. And again with that I have added a check constraint there where the status should be pending, completed, or failed. Fine. So if I run this, it will create the table. Okay. And let's try inserting the values, right? Insert into payments values. So it's payment ID, right? So payment ID, let it be 101, comma, amount, let it be 100, 1000, let it be 1000, and let it be completed. Okay, great. And one more I will do, but here I will mention the payment ID, and the amount also. Remove this. Let it be 1001 and let it be 102. Okay, I think remove this also. So it's all right. Now we'll run both of them together. Got inserted successfully, and I will refresh the page here, and you can see that payments is present here, right? And if I zoom it, you can see that 101,000 this is inserted. But why this didn't got inserted? Let's check again. Let's run it again. Okay, let's run again. Okay, look, 102 payment ID, 1001 with amount and pending. The status here is pending because I did not give any particular status here. So it's by default. So this is how a default and a check is used all together. Fine. Now let's see using alter to add default. Let's try this. Okay. Alter table payments. Fine. Alter column. I want to alter the column status and want to set the default as active. Got it? Meaning I'm trying to alter the sorry, I have taken the wrong table, I guess. No, correct. So payments table I'm taking, and I'm trying to state the default as active rather than being pending. Okay, let's try running this, and if I come here and if I run this query, you will see that it's still pending, of course. But what I will do, copy this, paste it here. After this, let it be 3. White string error. Payments check 2 is violated. Let me do one thing. Let me put something here. Suppose let's put me fail. Let me put failed here and try running this. And before that, let me just put here status. It's getting affected. So if I come here and if I run it again, look, it got inserted, right, successfully. Okay. So we can see that after adding the status also it's getting inserted. Okay. And suppose again, if you want to drop something, right, drop default. How you gonna do it? Alter, it's very simple. Alter table Let's take the payments table itself, payments, and alter the column name, status, drop the default. Look, this which like we have learned about the alter, like alter column, alter table, right? So here we are just trying, we're using those syntaxes and doing the things, right? These are the things you should be knowing. So it's dropped. Now if I run create show payments again, I can see that if I come here, there is no default present anywhere, right? Constraints, you can see, wait, from where I did it, from payments, right? Okay, so here you can see that status default, like status was active here, right? Previously default, if you remember. Now it is not present, but we do have the check, right? Check is something else, but default is something else, correct? So this is how we remove the default. Now also the point you should be knowing that default works only when column is not mentioned. If you give null, database respects null. Okay, let me write it down here. Note, remember that default works only, as you have seen, right, that when I mentioned, like let me complete this. Defaults works only when column is not mentioned, right? You have seen that. But if you give null, database respects null. Fine. I hope you get it. Okay, so this was all about the syntaxes and more on defaults. Let's go ahead and try to understand the few common mistakes which people do. Common mistakes or mistakes, whatever. First one they do is thinking default works with null. It does not. Okay. Forgetting column order in insert statement basically. Suppose you forgot the column order, right? Then it might be a chaos and you might not know which one is what, right? Not combining with not null where needed. Fine. Fourth one, assuming default always applies. Fine. We assume the default always applies, but no. If you put the value there, it will override the value which you added, right? So these are the four things you should keep in mind, or what the mistakes which usually people do without knowing it. Okay. So this is all about default constraint, and I hope you understood the topic. So guys, let's move to the next topic. Moving on to the next topic, which is enforcing business rules. So in this particular topic, we are going to understand how SQL and this constraints plays a important role while writing the query and in business perspective. So let's begin with it. And first, let's try to understand what are business rules. Okay, business rules equals real world conditions that data must follow. Okay, if I take an example here, examples, a user must have a unique email, right? Suppose order amount must be greater than 0. Employee must belong to a valid department. For example, status should be limited values only. So these are few of the examples of what real world conditions that a data must follow becomes a business rules. Going further, like DB constraints or database constraints equals tools to enforce these rules. Correct? So so if we have these rules, right, we have these conditions, we have this perspective like the data should be follow this particular norms, and to implement that and apply those things, the database constraints are used so that we can enforce this kind of business rules. So constraints are not random, they represents the real business logic. Fine. So if I write this point down, constraints are not random, they represent real business logic. Okay. Now, so this is the overview I tried to give you. Like I was trying to give you this particular overview now. Let's move ahead and try to understand like key idea of this chapter. Okay, key idea of this chapter. Why we are learning this chapter, or why we are learning this particular concept? What is the need? Right. So till now, you learn or we learn, whoever learn. Okay, that we learn about primary key. We learn about foreign key. FKPK means primary and foreign key short forms. Okay, we learn about unique key. We learn about not null. We learn about check default, right? We learn about all these keywords or constraints. Now what we are gonna do, now we combine all of them in one system, like in a real world scenario. Okay, so we are going to do that now. So for that, let's take the scenario as e-commerce system. Fine, let's take this particular scenario, and what we are going to do here, we will create customers, products, orders. Okay, we are going to create these three tables, and we're going to see how the real world scenario works. Fine. So coming back to our MySQL workbench. So first I have pasted this particular query, which is basically we are creating a customers table having customer ID as primary key, name as varchar which cannot be null, email as unique plus not null, and status as you can see active, or and the like default is active, and whether we check whether the status which is given whether it's active or inactive. Okay, these are all the constraints we are used here, almost all I guess. Foreign key we haven't used here. Okay, so let's go back and pages one, customer stable. Fine. So it has primary key, it has not null, then it has unique, default, and then check. All right. So these are the things which are present here. Okay. Now let's do for the step two. Okay. Products table, and in the left hand side I can see that I already have a products table, so I have to drop that down first. Drop uh, products. So this will throw in a drop table name. It's saying please mention the DB, so I'm going to mention the DB now. Use company DB. And that's done. Right, now I will clear this up. So I pasted the products table query here. Then let's go and paste the step 3 also, which is orders table. Orders table. And on the top, this is like customers table, right? I will explain the table skeleton. Just hold on. So this is the orders table. And if something you don't know here, don't worry about that, because since I have to give you the complete understanding of the real world scenario, there might be some of few of the things which you don't know. Okay, or which we have not covered till now. I would say in that manner. So this is a products table. In products table, what we have done: product ID is a primary key, product name is varchar, and it cannot be null, and price is decimal. It is not null, and price has to be greater than 0. So this is a check we have put here. Coming to orders table, you can see there are a lot of parameters present. Order ID, customer ID, quantity, product ID, quantity which cannot be null, and quantity has to be greater than 0. The check we have put here. Order date is the date, and default is today's date. Now status, you can see it's pending, and if we put the status, that's a check constraint, it could be pending, shipped, delivered, right? Then there is a foreign key, which is customer ID from this particular table, and which is going to reference the customer's table customer ID. We know this thing, right? On delete cascade, fine. Now foreign key is also product ID from this particular orders table, which references the products table's product ID. Got it? Now let's come back to is what products table, right? Products table. It has like price must exist, basically not null. Price must be valid, greater than 0, correct? Then comes the third table, which is a lot of things. So let me write it down first. Orders table. And I'm going to put this here. So basically this table combines everything. Okay. First is primary key. Second is foreign key. Third is check. Fourth is default. Fifth is cascade. Okay. And cascade means what? If customer deleted, orders are also removed, like basically dependent orders of the customer was also removed. Okay. And default, we know about default FK and everything, right? So that's all right. Fine. I know this looks a little bit of confusing, but this is just the description of the table. That's it, nothing else. So what I will do, I will select everything and I will run it. Let's see, hopefully it's run. There is no orders table, right? Okay, there is already. So I have to drop first. Drop table orders success. Wait, which table did it create? It created customers table, right? Okay. Okay, now all the three tables has been created. Customers, then products, then orders, right? Everything is fine. Okay. I will just reduce the size a little bit. Okay, now I'm going to do what? I'm going to insert the data. Fine. Look, insert into customer, insert into products, then there is insert into orders, right? Where I have given that specifically. Now, if you can see in the insert, customer, what it was, customer ID, name, email, and status, right? So I wrote here default. Why? Because I want it to take the default value. Or what I could have done is that I could have written these three column names and then and only have written these three column names like here, which I have done, like quantity, order date, and everything, right? I have mentioned this column, so it will take only these values and it will run. I hope you know this thing, right? Nothing to explain here. Just in case if you don't want to write the mention the column names, you can just write default here. Okay. So remember this. This is a new thing you have learned today. So we'll run this. Let's see what happens. Got ran successfully. Now what we're gonna do? Okay, we'll just customers orders. Then it was product. Okay. So if you see, we have Rahul there. In orders, we have the order ID and everything stuff pending. And here also we have everything stored, correct? Great. Now let's test the business rules one by one. So what I'm going to do, I'm going to create one more SQL query section, and I'm going to write the heading as test business rules. Okay, let's try to do this with something new. Let's go with okay, case one, okay, which is duplicate email. Fine. What I'm going to do here, insert into customer stable values stu, then suppose Amit, then Rahul at the rate gmail.com, comma, then default. Okay, let's see what happens. It throws an error. It says a duplicate entry Rahul at the rate gmail.com for key customer email. So that means that a different person cannot have the same email ID. It's not possible, right? It's not possible. So that's one of the thing, because and this is blocked by unique. Okay, let's go for the case 2 now. Case 2, invalid price. So it is going to be insert into products values 102. Suppose item name is phone, then by mistakenly I have entered -1000. Okay, it will throw another error that check constraints product check one is violated. Basically, if you can see here that this has to be greater than 0, right? So I given -1, so of course. So I will write blocked by check. Here comes the case 3, invalid quantity. Okay. No, let's take the case 3 as invalid customer first. Insert into orders table values 1002. Okay, 5 comma 101 comma 1. Then we're putting all the default values here. Fine. Default. Fine. Coming to orders table, we can see that we already have 1001 order ID, one customer ID, 1001 this, two in this, right? Now here what we have done, we have written here 5. 5 is in the second section. That means customer ID. Now you know that if you come here, customer ID is a foreign key on that on delete on cascade, right? And meaning of delete on cascade is if customer is deleted, order is also removed, right? So it is dependent upon the customer's ID. So customer ID has to be present there. Correct? Makes sense. So if I run this, it will throw an error that cannot add or update child now. A foreign key fails. So since we don't have this ID 5, customer ID 5, that's why it's throwing the error. Got it? Blocked by FK. Customer ID issue. Okay. Let's go for the case 4 now. Case 4, invalid quantity. Insert into orders values 1003, 101, then the 0 will be there, then the default will be there. So in orders, we have entered the quantity. Let's come back here in the orders. Let's see what we're cooking here. So here you can see quantity is integer and it cannot be null, and quantity has to be greater than 0. And here I have given 0 as the quantity. Look, it will throw the error. Check 1 is violated. So again, blocked by check. Fine. Then comes the case 5, the last one. delete customer. Very easy, right? So delete from customer. If you don't know this query, don't worry about it. Okay, where customer ID equals to 1. Now it got successfully deleted, right? Why? It existed, right? That ID exists. That's why. Order also deleted. Cascade scenario. So if I come back to the orders and if I run this again, no orders is present, right? So this makes this things clear, I guess. A real world scenario, how it works. I try to build up, bring up everything here, and create the tables and do the stuff. You can use this same table and insert a lot of data in different ways, and you can just play around. So this will help you a lot to gain more practice and understanding. Okay, so this is all about enforcing business rules, and I hope you understood the topic. So let's move ahead to the next topic. Thanks for watching this module, and check out the next video in the core playlist. Explore other related modules there as well. Don't forget to like, share and subscribe.